Good morning student. Today we will discuss depression in freezing point. In lecture number 10, unit 2 solution. So our topic is depression. Depression in freezing point. Of solvent. Depression in freezing point of solvent. Before discussing this topic, depression in freezing point, we should know the definition of freezing point. We generally know freezing point means the liquid convert into solid. That means the temperature at which the liquid is converted into solid. That means dynamic equilibrium is established between the liquid phase and the solid phase. That means vapor pressure in liquid phase becomes equal to the vapor pressure in solid phase. That means definition of freezing point we can write like this. So definition of freezing point. Freezing point definition. It is the temperature at which vapor pressure of substance definition of freezing point is like this. It is the temperature at which vapor pressure of substance in a liquid phase becomes equal to its vapor pressure in solid phase. That means vapor pressure becomes equal, and at this temperature liquid will start to convert into solid form. That means this temperature is known as the freezing point. We know very well for water, freezing point is 0 degrees Celsius. That means 273 Kelvin. That means at this temperature water is start to convert into solid form. Now topic is depression in freezing point. Depression means decreasing in freezing point. We know very well solvent and solution. When non-volatile solute is added in solvent and solution is formed, solution having always lower vapor pressure. That means decreasing in vapor pressure. Pure solvent having higher vapor pressure. Obviously, therefore, when the non-volatile solute is added in a volatile solvent, vapor pressure decreases. That means obviously freezing point is also decreases when the solution is prepared. That means you can write like this. What do you mean by depression in freezing point? That means considering one component as solvent and the second component as a solute. Now TF0 means the freezing point of pure solvent. Now non-volatile solid is added in solvent and solution is formed, then freezing point becomes TF. So TF is the freezing point of solution. That means after addition of non-volatile solute in volatile solvent. Now depression in freezing point, that means freezing point decreases. That means when solution is formed, freezing point decreases. That means always TF0 greater than TF. Therefore, delta TF equal to TF0 minus TF, and this quantity is known as depression in freezing point. Remember, freezing point of pure solvent is higher compared to the freezing point of solution. This delta TF is known as depression in freezing point of solvent. That means when solution is formed, solution having lower freezing point. We can also derive Why the freezing point of pure solvent is higher? When we compare the graph of vapor pressure versus temperature for the pure solvent and solution, then we can get idea why the freezing point of pure solvent is higher. So plotting the graph, that means we are plotting graph here. Vapor pressure versus temperature graph. Temperature in Kelvin, vapor pressure maybe suppose bar with, otherwise atmospheric, that means ATM unit. Now we know very well as the temperature decreases, vapor pressure decreases. Temperature decreases, vapor pressure decreases. Suppose here solvent is there. Now for solvent, as the temperature decreases, vapor pressure decreases. That means vapor pressure decreases like this. Now suppose at this point, solvent will try to convert into solid form. That means at this point, like this. That means at this point, solvent, that means liquid phase, solid phase comes under equilibrium condition. That means this is the solvent in a liquid form, liquid solvent, and here this graph indicates the solvent, freezing solvent. That means freeze solvent. We can write here freeze solvent. That means solvent comes in solid phase. Here solvent is in liquid form and here solvent is in solid form. This temperature, when the solvent is start to convert into solid form, that means vapor pressure of the solvent becomes equal to its vapor pressure in solid phase. This temperature is known as PF0. That means freezing point of pure solvent. Now solution having always vapor pressure lower compared to pure solvent. That means for the under the same condition, suppose we are taking solution from here, lower vapor pressure compared to pure solvent. In solution, the solvent, when the solvent comes in solid phase, at this temperature solution will freeze, and this temperature is known as the freezing point of solution. As the temperature we are decreasing, that means vapor pressure decreases, and when this graph touch with the freeze solvent, at this temperature solution freezes, and this temperature is known as the freezing point of solution. That means this graph is for solution. At this temperature solution start to convert in solid form. That means this corresponding temperature is known as PF. So from graph it will be clear, always PF0 is greater than PF, PF0 greater than PF. Now this temperature difference is known as delta PF, and delta PF is known as depression in freezing point. Now how to calculate depression in freezing point? So for dilute solution, experimental results show that for dilute solution, depression in freezing point is directly proportional to the molarity of solution. That means delta TF proportional to small m, that means molarity of the solution. Now when this proportionality is removed, then we have to add proportionality constant to delta TF equal to TF into m. Remember this formula for the calculation purpose. Now what is KF? So KF equal to, KF is known as depression freezing point constant. Otherwise we can write freezing point depression constant like this, freezing point depression constant. Freezing point depression constant, otherwise molar depression constant. Otherwise it is also known as cryoscopic constant. cryoscopic constant. Now M is molarity of the solution. So molarity of the solution can be simplified, otherwise extended formula based on definition, numbers of moles of solute per kg of solvent. That means molarity can be written as like this: W2 into 1000 divided by M2 into W1. 1 indicate the solvent, 2 indicate the solute. That means W2 equal to mass of solute. Mass of solute is taken in gram always. Now M2 means molar mass. Molar mass of solute. Molar mass of solute. This is taken in gram per mole. Now W1, 1 means component 1, that means solvent, that means W1. W1 equal to mass of solvent. Mass of solvent is taken in gram. So when we are substituting this value, then we get delta TF. Delta TF equal to KF. W2 into 1000 divided by M2 into W1. So remember this formula for calculation purpose. Delta TF, KF, W2, W1 is known, then we can calculate the molar mass of solute. Suppose delta TF, KF, M2, W1 is known, then we can calculate W2. In short, 1, 2, 3, 4, 5 variables are there. 4 variables are known, then we can calculate the remaining variable. Now discussing on KF. What is the definition of KF? KF is known as freezing point depression constant, molar depletion constant, otherwise cryoscopic constant. The definition of KF. Look at this formula. Delta TF equal to KF into M. When molarity of the solution is 1, then delta TF becomes equal to KF. What is delta TF? Delta TF is depression in freezing point. That means you can write the definition of KF like this. It is depression in freezing point of solvent when molarity of solution is 1. That means unity. That means depression in freezing point of the 1 molar solution is known as the KF, molar depression constant. Now what is the unit of KF? The unit of KF, so from this formula, KF equal to delta TF divided by M. Delta TF having unit Kelvin. Now M means molarity, having unit mole per kg. That means mole per kg. That means when simplified, Kelvin kilogram mole inverse. Remember, unit of KF is Kelvin kilogram mole inverse. Now on which factors value of KF depends? So KF depends upon nature of solvent. That means KF is the characteristic value for solvent. That means for particular solvent, value of KF is same. But when the solvent changes, value of KF changes. That means different solvents having different value of KF. Now how to calculate the value of KF for particular solvent? So by using this formula, we can calculate the value of KF. Rm1 PF0 square divided by 1000 into enthalpy of fusion. That means R means universal gas constant, M1 means molar mass of solvent, TF0. That means the freezing point of solvent. It is taken in Kelvin unit. Molar mass in gram per mole. Here enthalpy of fusion, delta H fusion. That means enthalpy of fusion for particular solvent, and this is taken in unit joule per mole. At that time, unit of R will be joule per mole Kelvin. Proper consistency of unit must be considered during the calculation of Kf. So by this formula, we can calculate the value of Kf for different solvent.